Good morning, students. So, whether my screen is visible, I am inaudible.
Yes, sir.
Okay, right. So, good morning, students. So, the welcome to the module number 34, right, in the IC engine subject, right. So, in this class, we are going to see about the water cooling or indirect cooling system of an IC engines or an automobile engines, right. So, before entering this class, right, just we can recap what are the terms we discussed in last class, right. So, for the last class, we discussed about the basic introduction of the cooling system and the types of the cooling system, right. So, in this type, uh, the air cooling or a direct cooling system we have seen, right. So, air cooling or a direct cooling system we have seen in the last class, right. So, while the due to the combustion process, the heat will be generated, right. The heat will be generated in the IC engine, right. So that heat has to transfer from the cylinder walls from the engine, right. So from the engine into a surrounding atmosphere, right. So that is the cooling system, right. So that's the purpose of the cooling system, right. So for the direct cooling system, right, for the direct cooling system or air cooling system, so we have to transfer the heat, right, in the terms of the without any medium, we can transfer the heat from the system to the surrounding, right. So for that we are using the fins, right. So fins is one of the method for a cooling one, right. So we have to increase the surface area, we have to increase the surface area of the fin, right. Then what will happen, the contact surface to the atmosphere is more, right. So the heat will be uh, dissipated in easy manner, right. So we have to increase the surface area, right. So at the same time we have to see, right. So, so what is the surface area, right? So this is the fins, right? These are all the fins, right? So in this fin, see, it is the surface area, right? From here to here, right? It is the surface area, right? So if the surface area will be increases, right? So the metal surface will be increases. So automatically, what will happen? The contact area to the atmospheric air will be increases, right? So the heat transfer rate will be increases, the heat transfer rate will be increases. So if we are increasing the number of fins, right, if we are increasing the number of fins, we may get the high heat transfer rate, we can get high heat transfer rate. So the engine will get cools in easy manner, right. Then at the same time, the space between the fins, the space between the fins also, we have to optimized one, right. We have to use the optimized number of fins. Why? Because here the spacing between the fins, so these are the spacing between the fins, right. So if we are increasing the number of fins, so what will happen, the spacing between the fins may be reduces, right. So this causes the reducing the heat loss, right. So the increasing the number of fins, we may get the higher cooling rate, higher cooling, higher heat transfer rate, right. Then the space between the fins will be gets reduces, means it will be reduces the heat transfer rate, right. So the number of fins and the spacing between the fins are important one for the direct cooling system or air cooling system, right. So here I mentioned the three types of fins, right? So the rectangular fin, the trapezoidal fin, and the triangular fin, right? So while comparing these three, right? So the rectangular fin may get a lower efficiency, right? It may get some lower efficiency. Why? Because you can see this area is called the root area. This area is called the root area, right? What it means the fins, right? So where the spin will be connected to the cylinder wall, right? So that area is called the root area, right? So in the first one, right? So for the rectangular fin, so the entire area will be common, uniform, right? So the area will be the uniform, right? So here you can see, here the area will be high and here the area will be low, right. So at the same time, here you can see area will be high and area will be low, right. So what it indicates means the temperature difference, right? So initially the temperature difference between the atmosphere and the cylinder, right? So where it can be high. So at this point, at this root point, the temperature difference will be high, right? So it will be gradually reduces, right? At the tip of the fin, right? At the tip of the fin, so the temperature difference will be a minimum one, right? So where the temperature difference will be minimum at the tip, so there we can increase some type of efficiency, right? So this is about the direct cooling system or the air cooling system, right? So here we have some advantages, right? So it's a very simple in design, right? So it's very simple in design. So it is not required any other mediums or any other devices, right? So only the casting of the fin is enough, right? So while manufacturing the engine, so at the time we can add the element of fins, right? So that's enough, right? So there is no any other elements, any other element with the water jackets and the coolants or a pipeline, so nothing's there, right? So the maintenance costs will be low and the manufacturing cost also low, so it's very cheaper one, right? So if we have any coolant medium or radiating medium or pipe connection, so there we can have some work, right? So there we can have some problems. So it may be an anti-corrosion one. So it may be operated low temperature or high temperature. So what are maybe antifreeze solutions, right? So that term also here not there, right? So the this is the advantage of the air cooling system. Right. Then the disadvantages and the limitations we have for the air cooling system, right? So here the heat transfer rate is comparatively to the other systems. So here it will be a very lower one, right? So why? Because the heat transfer coefficient of the air will be a very low one, right? So the heat transfer rate, well, comparing to the other cooling system, so here the heat transfer rate will be a very minimal one, very low, less one, right? So that is the main disadvantage for this air cooling system. Then the cooling is not a uniform one, right? So it is not a uniform one. Why? Because so it may cause some distortions in the cylinders, engine cylinders, right? So then the wall temperature is the temperature difference between the wall and the atmosphere will be high, right? So the wall temperatures are high, right? Then in fact, if we are using any additional terms, means we have to use only the fan, right? So that fan maybe improve the heat transfer rate, right? So it maybe improves the heat transfer rate, right? So that also, if we have to run the fan, right? So that fan has to run, means that fan have require some power, right? So if the engine will be producing the 100% power, means so 5 to 10% power will be utilized for to run the fan itself, right? So the fuel consumption is high, and then the system will be noisy, and for high compression ratios, right? For the high compression ratio, we can develop the high efficiency as well as the temperature developed in the engine is very high, right? So it is not suitable for the high compression ratio engines, right? So the compression ratio will be a limited one, right? So this type of the air cooling system will be used in the medium and the small IC engines, right? Small range of IC engines. For example, the scooters and the motorcycles, we can use this type of the air cooling system, right? So this is about the air cooling system, right? So this is the air cooling system or a direct cooling system, right? Then the second one, right? So the second one will be the indirect cooling system or a water cooling system, right? Indirect cooling system or a water cooling system, right? So here you can see we have five types of the water cooling system will be there, right? We have five types of the water cooling system is there. So one is the thermosiphon cooling, and second one is the improvement of the thermosiphon cooling, right? So here without pumping we are using the thermosiphon, right? So here we can use the pump assisted the thermosiphon cooling or a forced circulation cooling, right? Then the cooling with thermostatic regulator, right? So we have some regulator and we have to cool the engine, right? Then the pressurized water flow of cooling and the evaporative cooling, right? So we have five types of the water cooling systems, right? So we can see one by one. So the first one is the thermosipan cooling system. The first one is the thermosipan cooling system, right? So anyone just answer me, right? So what about the density? Whether the temperature affects the density or not? Whether whether the density will affects or uh, anyone answer. What about the density? If the temperature will be differences, what about its density? Anyone?
Decreases.
Right. So depending upon the temperature, the density may be varies, right? That's only it will be called as the compressible or incompressible fluid, right? So in this thermosipan cooling, right? In this thermosipan cooling, the system is designed, right? So that the water it may be circulated naturally because of the density differences, right? So naturally because of the density differences, depending upon the temperature, right? So if the temperature will be somewhat hot, right? So hot water will have some low density. At the same time, the cold water will have some high density, right? So the system consists of a radiator. You can see the diagram, right? The system consists of the radiator, right? So having two tanks. One is the upper tank, and one more is a lower tank, right? So the upper tank and lower tank is connected, right? So upper and lower, the water jacket cylinders, right, with respectively will have some flow through pipes, right? So respective through pipes will we have to connect, right? So is it that the diagram will be clear? You can see the diagram. The diagram, either the diagram will be clear. Anyone? Okay. So the hot water, right? The hot water in the jacket rises and it will be flows into the upper tank due to the lower density, right? While comparing to the cold water, right? And the cold water from the radiator flows to the lower water jacket to replace the hot water condition, right? So you may remember this one. The hot water in the jacket rises. You can see the diagram itself, right? So where the hot water will become and where the how the connection will be there, right? So the hot water in the jacket rises and it will flows into the hot upper tank due to the lower density well compared to the cold water, right? So and the cold water from the radiator flows, right, to the lower water jacket to the replace of the hot water, right? So from the upper tank, the water travels down the radiator tubes across which the cool air passes drawn from the fan, right? So it will be driven by the engine crankshaft, right? So you may see the fan also, right? So from the upper tank, the water travels down, right? The water travels down the radiator tubes across in which the cools the air, right? Cool the air passes, right? The air will be passes by the fan, right? So which is driven by the engine crankshaft, right? So in order to increase the rate of heat transfer, right? In order to increase the rate of heat transfer, the surface area of the radiator is exposed to the air blast, right? So it will provides with the fins, right? So you can see your have you seen the radiators? இப்போ ரேடியேட்டர்ஸ்லாம் பார்த்துருக்கீங்களா எப்படி இருக்குன்னு? Anyone?
Yes, sir.
Right. So you may see the radiators, right? Uh, just wait a little. Right. So uh, right. So in this radiator, so how the water will be travels? So the water will be travels in this direction, right? So while the water will be travels from this direction, so here we have some fins, right? So here we have some aluminum fins. That fin will have the zigzag direction. The fins will have some zigzag direction, right? So that will increase the heat transfer, right? That will increase the contact area, that is a surface area, right? So this type of the cooling system is called the thermo cooling system, right? So it will be limited for uh, low, sorry, medium, right? So small and the medium scale of engines, right? So we are using the thermosipan cooling system, right? So you can see it's a very simple one, right? So here we have the two tanks. One is the upper tank, and one more is the lower tank, and the in between the radiator will be there. The radiator will be there, right? So here, what will happen? Here the engine will have some temperature, right? So what will happen? We have to supply the high density water, right? So once the water will be gets heated, so what will happen? So the water density may be reduces, right? So it will be connected through the radiators, right? So here the density will be low, right? Here the density will be low. Why? Because the upper tank having some hot condition, right? So here the density will be low, right? So once the fan will be rotates, right? So it will be driven by the engine crankshaft, right? So it will be driven by the engine crankshaft. When once the fan will be operates, right? So what will happen? So the air will be passing, right? So the air will be passing, right? So at the time, what will happen? The air, right? So the air gets some um, absorb some heat, right, from the hot water. Then we can supply the cooling water in the lower tank. Then it will be circulated again, right? So this type of the system, right? This type of system is called the thermosipan cooling system. Thermosipan cooling system, right? Whether it is clear? It's a very simple diagram, right? So it's a very simple diagram. Is it clear? Anyone?
Yes, sir.
Right. Then uh, here it is suitable for very low capacity engines only, right? This type of cooling system. Sorry, right. So this type of cooling systems will be used for very low capacity IC engines, right? Then here we have some limitations also, right? So the radiators need to kept above the engine level, right? So why? Because the water has to flow due to the density difference, right? So the radiator needs to kept above the engine cylinder level for the flow of water, right? For the flow of water, it will be passing through the engine, right? So due to the gravitational force itself, it will be functioning, right? So the radiator need to transfer, radiator need to kept in a above level, right? So above level of the engine, right? So that's a very disadvantage one, right? Then the circulation of water is established only when the engine becomes a hot, right? So once the temperature difference will be there, then only the water may be circulated. Then only we can get the density differences, right? So that also a disadvantage one, and it is not suitable for the heavy type engines, right? So the heavy type engine, and where the high heat transfer is required, there we can't use this type of the cooling system, that is the thermosipan cooling system. Then the water level in the radiator, right? The water level in the radiator should be kept higher than the delivery pipe, right? So otherwise, what will happen means the circulation of the water may be grease, right? So causing the excessive temperature rise of the cooling system, that is the cooling water with a steam formation, right? So it causes the formation of steam packets and unequal heat flow over and the overheating of the engine components, right? So these and all very disadvantage, very limitations of the thermosipan cooling system. Then the temperature of the cooling water, should not be allowed above the 80 degrees Celsius, right? So the water cooling, the circulated water temperature, it should not be allowed exist of beyond, that is the 80 degree Celsius, right? So this is a main disadvantage, right? This is the main disadvantage of thermosipan cooling system, right? Then uh, due to these disadvantages, we have to improve some modification. We have did modification, right? So that type of system is called same, right? So here you can see the setup will be the same, right? So here also it will be called as the thermosipan cooling system, but it is pump assisted one. It is pump assisted one, and the circulation will be a forced one. Why? Because so here you can see this system. and this system will be included, right? This system will be included, right? So the remaining and all you can see. What about the last diagram and this diagram? You can see the last diagram, same, the upper tank, lower tank, radiator, and the engine component fan will be there, right? So here also you can see same, the fan, the upper tank and lower tank and the radiator, the same setup will be there here also, right? So here it is called the forced circulation of cooling, or pump assisted one, right? So the drawbacks which is encountered with the previous one, that is the thermosipan systems, are overcome, right? To overcome, so we are introducing this type of the cooling system, right? So forced circulation cooling system, right? So in this forced circulation cooling system, a pump of the centrifugal type is assisted, right? So we are using a pump, right? So the pump will be a centrifugal type, right? So that pump will be assisted the water circulation in the water jacket, and water circulated in the water jacket. Then the pump is driven by the engine itself. The pump will be driven by the engine itself. So the introduction of the pump ensures the positive circulation of the water and at all working conditions, right? At all working conditions. Since the cooling of the engine is independent of the temperature differences of the hot and the cold water, right? So it may results into the overcooling of the engine, so which affects the thermal efficiency of the engines and its working conditions, right? So this will be the disadvantage by the working, right? So with this type of the cooling system, right? So in this cooling system we have two terms, right? One is the pumping one, and second one is the thermostats, right? So the cooling with the thermostat regulators, right? So cooling with the thermostat. So here you can see the third one, right? So here you can see we have the five types of the cooling systems, right? So one is the thermosipan cooling system, and second one is the pump assisted cooling system, right? So in this pump assisted cooling system, we have introduced the two terms, right? So one is the thermostats and the pump, the centrifugal pump, which is assisted to the thermosipan cooling, right? So the pump will be helps to pump the water, that is a low cooling water, to the engine, and it will be transfers, it will be absorb the heat, then it will be passing to the radiator, right? So in the radiator, what will happen? The hot water will be get some cooled, and it will be again circulated by the pump, right? So which is assisted, the pump will be runs by the engine, right? So here we are using the two terms, one is the pump and one more is thermostat, right? So the thermostat, it will be regulates, right? So it is a one type of the cooling system, right? So the cooling with a thermostatic regulator, the cooling system will be the thermostatic regulator, right? So in this diagram you can see, right? So the cooling with the thermostatic regulator, right? So in this case, the pump circulation method, the operation of the pump is governed by starting and stopping the engine, right? So when the engine will be starts and when the engine will be stops, right? So the pump will be automatically runs and it will be stops, right? So depending upon the engine condition, right? Depending upon the engine starting condition, the pump circulation may be there, right? So this one type, right? So in some conditions, what will happen means once we stop the engine, right? So there the pump circulated will be a cutoff one, right? But after switching off the engine, after the ignition of the engine, so there also we have some heat in the engine, right? So that heat also we have to dissipate it to the atmosphere. So that heat also we have to reduce. That heat also we have to cool, right? So there, how the system will be works means by means of the thermostat, by means of the thermostat, right? So if the temperature difference will be there, so the thermostat will be works, right? So in this case, the pump circulation method of the operation, right? So the pump is governed with the engine. So when the engine will be starts, the pump will be runs, and when the engine will be stops, so the pump will be stops, right? So as the pump starts, right, as the pump starts, so it will start circulating the cold water to the water jacket and surrounding to the cylinder, and it absorbs the heat, at the faster than the faster manner, right? It will be absorbs the heat in the faster manner from the cylinder wall, and due to the large temperature difference, right? So as a result, the engine takes a longer time, right? The engine takes to longer time to warm up to the desired level of the temperature, particularly for the cold conditions, that is for the cold weathers, right? So to overcome this type of the difficulties, we have to introduce the thermostats, right? We have to introduce the thermostats, right? So it is incorporated with the discharge line of the radiator, right? So you can see the diagram, right? So in this diagram, so the at the bottom level you have the pump and the upper level, right? So from the upper tank to the radiator, that is the engine system, right? So there we have a thermostat, right? So the thermostat, it consists of the blows, right? So usually made of the copper or a bronze, and the sealed at the both ends, right? So the thermostat will have the material, right? So it will be have some blows, right? So the blows will be the copper one, right, or a bronze, right? So which is sealed by the both ends, either an upper end and lower end, right? So the blows are filled with a partially a liquid, right? So the liquid will be the volatile, right? The volatile liquid, right? So it will have some low boiling temperature, right? So low boiling temperature, right? So you may see the thermostats in your refrigerators, right? Have you seen your thermostat in refrigerators? Anyone? Anyone?
Yes, sir.
At the back side of the refrigerator, we have some a small tube, right? So the small tube will be a blow type one, right? So in the blow type will have some liquid, right? So partially liquid will be there. So the liquid will be a volatile one. So it will have a lower boiling point, right? So it will have some lower boiling point, right? So when the engine will be started, right? When the engine will be started, the temperature of the water, it becomes a low one, and then the valve will be closed and it prevents the flow of the water, right, to the radiator, right? So such the water in the cylinder valve, right? So the water jacket, right? So it is available for the absorbing the heat from the cylinder valve or engine system, right? So the engine would be takes, right, so less time to warm up the uh, so what do you say? So the engine will take the less time to warm up for the cold starting conditions, right? So however, the temperature, right, the temperature of the water exceeds the boiling point which is available in the thermostat, right? So the volatile liquid, right, so it is filled in uh, the thermostat blows, right? So due to the temperature difference, the heating by the water jacketed water, the blows will be expands, right, in a axial direction. So due to the expansion of the liquid, in the blows, right, the expansion of the blows will allow the valve to lift from the seal, right? So gradually it will be lifts from the seal. So what will happen? So there then the cold water and the hot water flows will be started, right? So even the engine will be in stop condition, so there is some temperature difference, right? So at the time it will be works, right? So you can see the diagram. So in this diagram we have the two valves, right? So valve will be seated up the bottom and the lower, right? So then we have some blows in the blow. What will happen? We have a volatile liquid which is having the low boiling temperature, right? So if the temperature difference will be more in the engine and the atmosphere, right? So then the volatile liquid will expands, right? So once it will be expands, what will happen? The wall seats will be opens, right? So it will create a path. It will create the pathway from the two tanks. One is the lower tank to the upper tank. So then after stopping the pump, the thermostats will be works, right? So you may understand this one. இது புரிஞ்சாப்பா உங்களுக்கு?
Yes, sir.
Right? So it will be a very easy one, right? So in this class we have seen only these three, right? So what are the terms we? So for the next class we can see the pressurized water cooling system and the evaporative water cooling system. Right? Next class we can see that one, right? So It's a very simple one, right? So do you have any doubt in this? In these three types? One is the thermosifan cooling, the pump assisted thermosifan cooling, and with the thermostatic regulator. Do you have any doubt in this?
No, sir.
No. Okay, right. Then uh, Joel and Joel Shankar.
Hello, sir.
Joel அந்த பாத்தீங்களா அது?
Yes, sir. Partner, sir.
ஓகே ரைட். அப்ப நீங்க ரெண்டு பேரும் மாத்தி எடுத்துப்பீங்களா?